All right, you're listening to another episode of the CTO Advisor podcast. We have another returning guest, Matt Wallace, CTO of Faction, who provides multi cloud data services. And this is a timely episode. Got engaged with Matt as a result of my AWS Everyday series, where I'm reviewing an AWS product every day. And we got the EMR, which is a Hadoop based product service offering by AWS, and there's some nuance there. It's not it's Hadoop compatible, but it's not Hadoop in the sense that you're scaling out nodes. Really cool service from AWS, and Matt was troubleshooting Hive related issues. If you don't know what any of that means, that's fine. We're going to walk through this, but first, Matt, welcome back to the program.
Yeah, hey, thanks for having me. I'm super excited, and it's good to be chatting again. I've been watching the podcast. I caught your episode with Rob the other day. That was great.
That's a fun one, right? The platform group, the one I know it's another one of your passion topics as well. And we're going to get into a little of that. We're going to have two personas, which are pretty accurate. I think the only caveat is that Matt could carry both personas, but that's okay. I'm going to have the persona of the enterprise architect whose basic job it is to provide a platform to data architects, and Matt is going to play the role of the data architect. And there's a place where the two roles bleed, and we need to understand from a enterprise infrastructure architecture perspective and from an enterprise data architecture perspective, how do we communicate between the groups so that at the end of the day, when a internal customer or even external customer says they want to collaborate on a data product or project, and one customer says, hey, we use Hadoop and Hive, and the other one says we use Hadoop and Hive, there becomes a problem that is not as clear as it would seem, or even between internal groups. So, Matt, let's do some basic definitions because I need them myself. When we're talking about these frameworks, what are the fundamental building blocks of them in general?
Okay, well, I mean, I think that's broad, and I think from the things that I've seen, and we're talking about like large data sets, right? Everybody's got their databases and so on. But from this big data perspective, the things that kind of live in that ecosystem, especially things like, EMR. You have all these things that are built in the Hadoop ecosystem. So you had Hadoop, and Hadoop included HDFS. And over time, HDFS, which was a great way to take a bunch of commodity hardware and big drives and make it, resilient and performant, got replaced a lot as those things went to the cloud with object storage because object and HDFS look very similar in terms of the way that they see the world. And so it was pretty easy to put this abstraction for object in the hood. But then you had all these services over time that got built up on that, right? You've got Hive, you've got HBase, you've got Spark. And so over time, you went from um, Hadoop being built sort of as a data warehouse where a lot of the users they were BI people, they were running SQL queries. And it was just a way to do these, map reduce jobs to process massive amounts of data. And it started getting used for all kinds of other use cases like streaming, like analytics, like machine learning. And so I think there's been this flowering of this ecosystem. And so you have those personas where you've got, classic BI types of people. You've got the machine learning people who are kind of, split into that data engineer, data scientist, right? Where the data scientist people are really good at linear algebra and, all kinds of calculus. And the data engineer people are much more in the vein of they understand some level of infrastructure. They know how Spark and PySpark and PyTorch work and all those things. And they're trying to bring those things together. And as data has become more important, you even literally have people who are like data product managers where their whole job is to understand like where's the data live, how can we use it, to improve the business, where's the value come from, what's the next thing? They're treating data as a product. And it becomes really interesting to see the interplay of these. And of course, over time, like EMR is not a new service. It's one of Amazon's very first things. Like EMR, Redshift, Athena, they all feel like they're, quote unquote ancient in terms of cloud years. It's like dog years, and I think you see the evolution of these services has kind of tracked to some extent the evolution of these personas, right? Glue, which is a much newer service, feels a lot more like it was designed for those newer access patterns. So it's really interesting across the board.
So let's walk through a typical business journey that happens that I've seen. So I have this huge amount of data in a Hadoop data lake, the HDFS, and a data scientist sees it and like, oh wow, that is an awesome repository. I want to run some real time queries against that data set. You come in to advise on this setup. Traditional, whether we're talking about EMR or a ATFS built out cluster, and the number one complaint is I can't get real time queries done. The queries are taking they're batch queries and they're taking forever to get back results. What's the next step in the data journey?
Yeah, I mean that's interesting because I think you're skipping into a part where you're a little bit talking about performance, and this is actually one of the things that was really magical in my mind about the way I saw that evolution of the Hadoop ecosystem because you had the data that was there for that BI kind of scaled SQL for the MapReduce jobs, right?
Mm-hmm.
And when you saw Spark layered on top, Spark catered to that data scientist persona. And if you're using, something like PyTorch and PySpark, you can come in and and Spark understands it's living on top of Hadoop and it can just go in and access parts of HDFS. It can use it as an abstracted file system, and your machine learning people are off to the races. Now, I think the things become complicated when you start to ask the question. And you mentioned earlier, this idea of EMR being a place where you can have a Hadoop like workload and not necessarily worry about scaling the infrastructure. Because ultimately, your data science people don't necessarily want to worry about, that question. Now, of course, what's interesting is all of these tools, when you run a query against, say, PySpark, it's going to have this ability to basically farm that out into a set of jobs that then get parallelized across the cluster. So, I mean, much like anything performance, the answer to, hey, it's not running fast enough is, we'll scale out. And I think at least this ecosystem around MapReduce, it's literally that's what it was designed for, right? No matter how you're slicing it, whether it's classic, MapReduce on HDFS or whether it's Spark and it's accessing, objects in S3, you can scale out to kind of do a certain amount of that work. And of course, there's questions about how much can you scale out, and if you start looking at things like if you were doing, say, training, like an LLM, like the Chat GPT that everybody's talking about, it's not that simple, right? The question of how those things work, there's a limit to how much you can parallelize certain parts of that process. So, performance wise, I think scale horizontally. But yeah, I think one interesting thing that I've seen, and you kind of said, hey, there's this data here and I want to run with it. A lot of enterprises can't get that far necessarily because they've got their data teams and their data teams are stuck at answering the question of, hey, what data do we have? And where is it? What's the format? What columns does it have? How much of it is there? Am I allowed to use it? And even that question can be hard to answer before you even get to running a query.
And I think even and the reason why I asked the question around performance is that when pre EMR, I know EMR has been around forever, but pre me adopting EMR, my organization adopting EMR, if I started my journey in Hadoop and putting Spark on top of Hadoop from an infrastructure architecture perspective, engineering perspective, someone has to think about that. Like someone has to add the Spark nodes and can do the connecting. EMR makes that magical. I can just run the job. To an extent from the plumbing of needing to do the cluster configuration, all of that kind of stuff. I'm told it's easy. Okay, I haven't touched a Hadoop cluster in like 7 years. I don't know. It could be easy or not. I don't know. But there's this and this is where it gets interesting. Like there's the people that think like me. I think block storage, object storage, replication, uh, data protection. I think at that level of data interaction. And then there's people like you who have to think about, okay, how is this data stored so that, well, one, how is this data classified so that I can determine how it's best stored, so that I can determine how it's best transacted against. And I think there's a separation between people who provide the infrastructure and that level of understanding. And my understanding literally stops at I provided your OS, I've provided you maybe even an EMR type environment to go run with it. What am I missing in my requirements gathering to better serve you so you have the agility that you need to provide data services to the data scientists, the machine learning folks, etc.?
Yeah, I mean, it's so interesting because there's these layers, and there's a certain layer that has to do with the mindset of what you're going to do with the data and what data it is. And it really lives completely, those people are not at all concerned about anything that looks like storage. And so we start talking about block or object, even HDFS, it's like it barely is on the radar whatsoever. In fact, they almost want like a cookbook or a playbook that says, this is how I get to my data source. Let me worry about, queries. And, if it's the machine learning people, they're asking, what do I need to do to add a feature? How do I avoid overfitting a model? They don't want to talk about storage at all. And it's so fascinating too, because these are both distributed systems talking to distributed systems. Like if you think about like an EMR cluster that's accessing S3 as the backend for its data, like on one hand, you have the scale out compute layer, and you can create jobs. Those jobs can scale horizontally. And at the end of the day, the execution um, is something probably your data people, whether they're BI people or data science people, don't want to worry about. They want to write a query or things of that nature, or they want to load a file, from a target. They want to load a Parquet file directly into a data frame, say, and then they want to work with it. They don't want to worry about what's under the hood of that. Your data engineer is asking the question of, okay, what is underneath this abstraction layer, right? What is it? How am I storing it? Where does it go? How scalable is it? And so your data engineering team may be worried in a way that your data science team is not about, okay, how am I going to partition this table? What do the partition keys look like? Do I need multiple copies? Um, and those things are questions they have to answer to make it work. And those things still live another layer above that abstraction. Like I can run Spark and actually mount NFS and literally use a classic NFS based file system and load data directly into, say, a pandas data frame right out of a file from NFS. But is that the thing I want to do? Right? That's not necessarily infinitely scalable in a way that object is. And so there's a lot of questions you have to ask about how big is the data set going to be? Who's going to access it? How much parallelization you need? Is it going to move around? And incidentally, I mean, there's also a whole ton of other abstractions. If you look at something like nowadays it's Starburst, which is based on Trino, which came from Presto SQL. It's this system that does distributed querying where the data doesn't even necessarily live in the same spot. You run a query and you might have agents from Starburst that are out querying your data on the West Coast and your data on the East Coast and your data in Europe. And they're all actually completely different locations. And it's treating those almost like partitions and pulling together to answer that question. Or something like Alluxio, for example, that can abstract like different types. So you actually can have one common interface for your data science people, and whether it lives on NFS or S3 or a host of other things, maybe even your Postgres database, they can abstract that away and treat that as a unified data source. And all those things I think are separated from the infrastructure concern and how fast is S3 versus classic HDFS versus maybe if you're doing super performant things in AWS. I knew some folks that work at one of the really big tech companies that were doing a bunch of data science work inside of Amazon. And when they had active data sets, they actually loaded it all onto EFS because it was so performant. So they were using the file system abstraction because waiting for objects to load was just not quick enough for them. And so, sure, you have to have people to answer all of those questions. But of course, if people don't know where the data is and they can't use it effectively, which is more like a catalog metadata governance question, then It almost doesn't matter what's under the hood from an infrastructure layer. And of course, as you know, this is like the classic EA dilemma. If you don't give people things they need to do their job effectively, they kind of go solve it themselves. And then you end up with this sort of like weird sprawl and everybody does their own thing. And then pulling it back into governance can be really tricky.
So let's talk about that problem because I think that's where the core of my audience is at is this EA problem, which is I do understand that I need to know where the data is at. And not only do I have to know where the data is at, I have to give my data consumers and data users an interface in which they can identify and discover the data. Because I don't want, from an infrastructure perspective, I don't want them to go out and get the data a second time or a third time. This has happened to me. I've had people ship snowballs two or three times of the same data because they can't identify where the data is within the organization. So, talk about this kind of data cataloging, data discovery problem.
Yeah. I mean, it's interesting. And I'm obviously like, I have my own lens here because a lot of the folks that I work with, at Faction have that really super oriented, like multi cloud bent. And sometimes that's because they had a pattern that really worked in a cloud. And then they're realizing they really want to extend their practice to include some data that's on prem still, or they have a subsidiary or a partner that's in a different cloud. And they realize the pattern doesn't work there because they can't use whatever service. And I mean, a great example here, right, is you look at AWS Glue. It's got this embedded catalog. It's fundamentally began as sort of ETL as a service, right? Scalable ETL jobs, and it could kind of consume data from things like Kinesis. You could feed it in to do ETL and then store that in S3, and then every other service, like you've been talking like about EMR and Athena, they can then consume that data even using Glue as a catalog, right? Looking at Glue's catalog in order to say, like that way Athena can just show you what tables are available because it's asking Glue what's available. But then, that doesn't necessarily easily extend outside those four walls. And so they're trying to find those patterns that make sense, right? And this is where you start to see things like Databricks has their, I think they call it Unity catalog, right, which spreads across workspaces and keeps track of things, or stuff like Starburst, where they can have like a centralized catalog and they can act as that broker for all of that information. I think the commonality is everybody really loves it when they can make the catalog and that metadata more universal. There is definitely not that I've seen, from at least my sample size, any sort of like universal agreement on the right way to do things. It really just depends on where you are in that journey with your data, what kind of data you have, and what your willingness is, right? I mean, there is a trade off for those things. If you can tell your teams, we're just going to use AWS for everything, and you know that everything is always going to tightly couple, that your Glue and your EMR and your Athena and your Redshift and your S3 will always work together, there's so many problems you don't deal with, like credentials. So seamless to have like Glue have permissions to access S3 buckets. And yet, by the same token, you start, getting outside of those four walls and you start asking the question of, well, how do I, even if I have a connector for Glue, how am I going to manage credentials for this external data source so that Glue can consume it? And how do I do that securely? And you start getting into, a whole host of other problems. Sometimes it feels like you have to trade one problem for another, right? Because making that seamless for your data people is a lot more work for people that have to kind of set those environments up. And yet, I think in a lot of cases the results are worth it. But there's definitely some immaturity around all of these practices. I feel like no one feels like they've got it all right yet.
Yeah, I think you're making the argument for a data platform team. And I think this leads into this conversation around maturity and what happens when an organization, a mature, well, well disciplined organization that has maybe not strict rules, but they have frameworks around data governance, and they meet a team, whether through acquisition or collaboration, that quite isn't there, that hasn't thought it all the way through. So where's the mismatch? Like if I'm an organization and I acquire an organization, let's keep it relatively simple. I acquire an organization because they have the data that I want, and I'm just going to outright acquire them, but they don't have the this hygiene. And I get in, and this and the data catalog is all over the place. What's the journey to reconcile this challenge?
Yeah, I think there's probably this pattern that you recognize, right? Which is when you have these two kind of separate estates. And by the way, it doesn't even have to be as messy as you're talking about, right? Like you might have an acquisition, and maybe just because you want to merge the businesses, hey, it's synergies. But then after you acquire, you're like, hey, listen, we have our customer data, you have your customer data, but we're now the same org. We got to put these together because these data sets, it's not 1 + 1 = 2, it's 1 + 1 = 5, right? It's more valuable together. And it could be that they have similar patterns, right? Just one was in Amazon, the other was in Azure, and they have to normalize that somehow. But it turns out, when you have those separate states, even when there's super similarity, you're still forced to do one of two things. You have to kind of put them together, which usually means migration from one into the other, or you have to connect them in some way, which might be like real time, or again, you have to abstract them, right? And in a similar way, how you can abstract all kinds of other things, right? Load balancers to abstract, regional endpoints or things like that, to play into the infrastructure, folks' mindset. You might have, this is where something like, if you were to stand up, Hive server, and this is kind of how we got started on this conversation originally, you can have the Hive server that can actually, as long as it's got connectivity to these different data sources, you can actually have it act as a master repository for these things. And it's, by the way, that is by no means the single way to to have it. Like obviously, what Amazon is doing, with data zones, or what Azure is doing with Purview, or what Databricks does with the Unity catalog. A lot of these things are, they're relatively recent services. I mean, in terms of cloud timeframes, even super recent services, and a lot of them are all there to address this question of like, how do we unify data? I think actually what is really fascinating too is it's kind of part and parcel of that trend that you see among cloud providers to start taking services that really extend outside their four walls, right? They're acknowledging that data lives in other clouds, it lives on-prem, and this one is specific to that challenge of like, how do I unify all those data pieces? But I mean, going back to your question, it's like at the end of the day, abstraction layer, real time access, like that's where something like Starburst comes into play, or migration to merge them. You just say, listen, you guys have 2 years or whatever the time frame is, get all the data over here. And I think what's really challenging for the data people is even as this is happening, there are these like real seismic shifts in what you can do with these data sets. And I think I'm thinking about things like the Delta Lake technology that Databricks has that's open source, the Apache Iceberg, which is very similar, these things that are taking the format of data away from being vanilla Parquet and taking them into these worlds where it's a lot easier to abstract them a little bit more and have different views of the same data, or point in time copies of data without having to make true copies, right? Where they can actually, you could freeze certain data sets or present certain columns that are abstractions of the whole data set to other teams when they're not supposed to see everything, because there's so many use cases around that. I mean, that's a great example. I mean, if you look at the Amazon side, what they're doing with the data room side of things, where it's specifically meant to help organizations share data safely and securely with other organizations where they have a relationship, but they may not be able to share all of that data. And so they need compliance, right? Because they've got a table that's got 20 or 20 columns of data, but three of those they have to redact and remove to share it because they're not allowed to share it. So all those concerns, I think, kind of come into play, and maybe the path is different depending on what your requirements are.
Yeah, we talked about many of these challenges whenever I talk to pharma customers, and there's a desire to share data with academia, and you want to keep the proprietary bits of your data to yourself, but you want academia to see, the genome sequencing and the less undifferentiated data. But when there's a ton of it, you can get a lot of information out of. And so far we've been talking at the data layer itself. What we haven't even touched is the application layer. What makes this really complicated. As a data person, a pure data person, you can see that an organization has the data that you want, but that data is not given that it's in a Hadoop or a Hive type of catalog. It could be SAP HANA, it could be SAP ECC, it could be a Oracle Rec database. And when you talk about the reconciliation, making sure that you can either merge data and use the data. Transforming the data is not always an option. Not in place. I can't just take an SAP HANA database, merge it with a Hive data set, and now have one data source. Not easily anyway, not in that the transfer to extract the data and transform it and leave it in one single system. I may need a hybrid. I may need something on top of the two systems to transact, because I can't go back and change my business processes that are built on SAP.
Yeah, yeah.
So, we have all of these complexities around how do we enable the business to leverage this important asset without disrupting the business.
I think you're right, and I think this is why those products like the Alexios, like the Starbursts, like I think almost from the beginning, everybody who's thinking about data practices should be asking themselves, like, how do we set up a process? This is completely away from the technology. How do we have a process that helps us define as an organization where data will live, how we approve the paradigms for accessing that data? Because you can't, you just made the point that you can't centralize everything in a single way. 100% normalization will not happen. I think that's probably true for everybody who has any variety of data and variety of use cases. But on the other hand, like the cost of just going wild west and saying, well, everybody you just figure out, that makes no sense at all. That's like everybody doing their own cloud architecture, right? And so you kind of have to centralize to the point where there's going to be different requirements, and you have to put that substrate of these are the patterns that we approve of. And if you want to deviate from these, you're going to have to do a lot more in terms of getting those approved and things of that nature. And then with those patterns in mind, you can start implementing, some tools, right? And I think, there's some popularity and some growing popularity behind those platforms that normalize things. And I keep mentioning things like Hive, like Starburst, like Alexio, because those are examples in my mind of those tools that normalize. Like if you're a data scientist and you're connecting into Alexio, it can literally normalize querying data out of S3 and off a file system and out of a Postgres server for you, to the point where you can like write queries that join tables, as long as you understand the schema from those sources. The fact that the underlying storage for those, the underlying where the data lives, doesn't even matter to you, because you can join the schemas. It's a whole different problem, I think, and this is where some of the life science use cases start to be completely different from the data science use cases. So you mentioned life science and genomics. I've obviously played around a whole bunch with some of those genomic use cases. Um, and one of the funny things about that is, I mean, there's tons of information about the data, but at the end of the day, a genome is one or more. It's 66 gigabytes compressed roughly of gzip data. That's a human genome. The one I was using split into two parts, and that's the raw version, right? The thing that comes off the thing that reads your DNA, and then you can create the aligned file, the BAM file, and then from there you can do all this variant calling. But now you have to ask the question of like, there's so much to keep track of, because with that level of compliance, you're constantly asking, like, to your point, if we partnered with an organization to get this, how long are we allowed to have access? It Are there certain things we can do and not do? Think about the GDPR perspective. Somebody's got a right to be deleted, and if they put it and say get rid of everything you've got, you got to find all the data that person you got from that person or derived from that person and scrub it, that lineage, and that can be complicated. And so it's a completely different problem than the sort of like quasi-structured data where, you could kind of apply a SQL schema and it's, CSVs or Parquet files or things, but you still have to keep track of tons of data. And if you're an organization that does both of those, because if you're, doing pharma, you might have one team that's responsible for understanding how your billion-dollar drug does in the market, how many doctors are using it, is there some sort of like cohort that won't, prescribe it and why? But then you've got a whole set of scientists who are going over like a genomic data, and they're getting all this data from a study, and they go, listen, I've got 1,000 participants and I want to analyze which genes of my participants indicate that this drug will be successful, so I can kind of understand how it will fit as I take it to market. Same business, two wildly different use cases, wildly different data. And of course, you could probably have some kind of IT and cloud team and enterprise architecture team that in some way touches both of those. Isn't that crazy?
Yeah, and I'll add one last point to it, and we'll end on this note. Is there's a cross team that's trying to find new indications for the same drug. So they're trying to figure out what are doctors, what are the existing indications, and the indication is what the drug can be used for, as authorized here in the U.S. by the FDA, and what are doctors actually prescribing the drug for. An example is Ozempic is being used as a weight loss drug. Doctors can prescribe it as such, but the pharma company cannot advertise it as such. So how do the actual scientists, the bioscientists and pharma scientists, use the data, or can they use the data from the prescription information that they have from their ERP and healthcare systems to find new and test new indications of indications for the drug. So it's a fascinating problem, and something that I've given a ton of thought through. There's a ton of stuff that I just functionally don't have a grasp of. I've never managed a Hive framework. I've never solved a data problem in that way. So there's some things that I haven't quite grokked. But I hope this has helped you folks kind of get a sense of the scale of the problem, the different directions that you can go to. Matt, let's get in the plug for Faction. If people want to learn more about Faction, what do you do and where can they find you?
Sure. Well, factioninc.com is the URL. Um, yeah, factioninc.com is the URL. And we do multi-cloud data services. And I think, when we start talking about these cases of, hey, this team's in Amazon and this subsidiary is in Azure, or how do we interlink like on-prem with these cloud environments, we get, hip deep in that. And a lot of the reason I've been so interested in playing around with so many things like Hive is because that same problem of, how do I have a catalog that touches everything, gets even more interesting when you're starting to talk about cloud. And so, like, one of the things that we're able to do is get that data centralized, right? Very close to all the public clouds. And then you can do something like have a bunch of data that lives on Faction where you can access it equally as if it looks like it's in the public cloud, but you can get to it from Amazon, from Azure, from Google, from Oracle, all at the same time. And if you want to, replicate it to and from on-prem or access it from on-prem or from your co-environment, you can do that too. But of course, for us, that begged the question of how are you keeping track of that? And if 100% of your data is not on Faction, how do you normalize between your Faction data and your Amazon data and your Azure data? And that's where we started seeing Hive. And so, there is something pretty awesome when you're running a SQL query. You're literally joining table data at Faction with table data at Amazon and table data at Azure. But a lot of our customers really are in that same boat, right? They've got different teams in different places in different environments, and they're asking, how do I normalize this? Not only because they don't want to pay for two or three copies, but because there's more to having more than one copy. And this applies not just to data at Faction, but universally. If you start trying to make copies, then you have to ask, like, how do I know my version is up to date? If I did an insert in Amazon and somebody else did an insert in Azure, they're out of sync. And so, we kind of help with that problem. But dealing with all that governance concern becomes even more interesting because you're explicitly going after enabling those multi-cloud uses. But yeah, reach out.
All right. And if you want to find out more about the CTO Advisor, you can find us on the web, thectoadvisor.com. Matt, thanks for joining. Talk to you on the Twitters.
Yeah, absolutely. Much appreciated, Keith.